Excel is basically used for working with data, and when you enter data in Excel, it's obvious that you will have some kind of numbering assigned to that data. This numbering is referred to or known as sequences in Excel. And if this data is very huge, then numbering such large amount of data can be a nightmare. Also, this numbering can be in various formats such as numbers, alphabets, Roman numbers, some customized sequence such as number 1, number 2 and date series. The coolest one is when you already numbered your data but then had to add more names, you can actually set up your Excel to detect new data and generate sequence for you. So, how many of these different types of sequences you already know? And do you even know that there are 5 different ways? Yes, note that 5 different ways of generating these sequences? If not, then this video is for you. In this video, we will understand each of the sequences that you are looking at your screen and various techniques of generating these sequences. You might already know a couple of ways, but there are some advanced techniques to automatically generate some specific sequences which would be time consuming to generate otherwise. There will be small but important details during the video here and there, so make sure you watch the entire video. The video is divided into 8 subsections or chapters which will help you to jump to any specific chapter ahead, or in case you want to revisit any chapter again, you can also jump to a previous chapter. So let's start with the first sequence. The number sequence. This is the most common sequence that you might already know how to generate it, but let's see if you know some really cool features that Excel has. We will go over 5 different ways of generating this series. So let's start with our first technique. First is very common, the fill handle, which is this little square located at the bottom right of an active cell. Simply enter first 2 numbers, select both, and drag the fill handle up to a row of your requirement. This works for both a row and a column. Second is double click. For this technique, it is required that you must have your data entered first. This won't work without data. Enter first 2 numbers, select both, and double click the fill handle. That's it. We have our series here. Third is using sequence formula. Now this formula is quite powerful, yet it can be confusing at times. But not to worry, we will look at all the different variations of this formula. The sequence formula takes 4 arguments. First is rows, second is column, then start, and last is step. Start is the number from which you want your sequence to start, which is usually 1. Step is the progression of sequence, that is the difference you want between 2 numbers. We will talk about the first 2 arguments, rows and columns, when we look at the examples. Let's start with a very basic example. Let's look at example A. We have a formula is equal to sequence in parenthesis 10, 1, 1, 1. It has generated 10 numbers. The thing to notice here is that the sequence has been generated vertically, that is in the rows, and has occupied just one column, column A. The argument 10 implies that we want our sequence to occupy 10 rows and 1 column. This is what normally you would look to generate for your data. Just change the number of rows, that is the first argument, to maybe 20 or 50 or 100 based on your requirement. Alternatively, you can also use is equal to sequence in parenthesis 10, where 10 is the first argument, that is the number of rows, and by default this formula will take the remaining arguments as 1. Now example B. Here we have changed our second argument, that is columns, from 1 to 2. You see the difference where the sequence was just occupying 1 column here. The current one is occupying 2 columns and 10 rows. It starts with row number 3, first fills out the columns and then goes to next row. The sequence starts from 1 in column B, goes to next column C, generates number 2, finally moves on to the next row number 4. This continues until it fills out 10 rows. You can literally have any number of finite rows and columns in the first 2 arguments. You can play around and can see amazing sequences like this. Just simply type in is equal to sequence in parenthesis 10,000, 1,000, 1, 1 and see the result you get. Let's move on to our example C. We can generate multiplication tables. Use is equal to sequence in parenthesis 10, 1, 2, 2 for a table of 2. We are starting our sequence from number 2, that is the third argument, and jumping and stepping 2 numbers from here. Simply change the last 2 arguments to generate the multiplication table of that number. For an example, to generate the table of 3, just type in is equal to sequence in parenthesis 10, 1, 3, 3 and so on. Now let's look at example D. You can also use this formula to generate negative sequence. Here we are starting with number 5 and reducing the sequence by 1, that is -1 as the fourth argument. So we have our negative sequence ready. That's all about sequence formula. Let's look at our fourth technique of creating sequence, that is using fill menu option. On the home menu, you will see a rectangular icon with downwards arrow, or if you are using a bigger screen, you may see fill written on the side. Let's enter number 1 and select that cell. Go to fill and then click series. Just like sequence formula, here you can select whether you want to generate series across rows or columns. For now, let's just select columns. Next, select linear. Since we already have our starting number here, we have to enter step value, that is the difference between 2 subsequent numbers, and the stop value, that is the last number we want in our series. Enter 1 and 10 respectively. Click OK. Simple and easy. Next, let's enter number 1 and 2. Select both the cells and at the same time extend your selection up to row number 11. Again, go to series, select columns. This time, select autofill and click on OK. This feature automatically detects the pattern of the numbers that are already entered by you and generate the series. Again, let's enter number 1, select that cell, go to series, select columns and growth. Enter step value as 2 and stop value as 50. Each number is multiplied by the step value, that is 2, and stored in next row and so on until we reach the stop value. Since 32 into 2 is 64, which is greater than 50, our series stops at 32. We will look at the last type, date, later when we talk about date series. So let's look at our last technique of number sequence, which is dynamic sequence. This is the most useful technique and will save you a huge amount of time and will also update the numbering in case you modify your data. So let's look at an example. We have 2 columns, series number and names, under which we have 8 names as of now. We will use the same sequence formula here, that is equal to sequence. Out of 4 arguments, only the first is mandatory, that is the number of rows. Instead of explicitly specifying a number 8, let's use another function that can provide us a count of non-blank rows under column B. For this, use function countA and provide a range of column B, that is from B2 to B1000 for now. What countA does, it returns non-blank rows for a given range. Hence, for our current example, it will return number 8. That is exactly what we want. Let's use this function inside our sequence function and see the magic. That's it. Series is generated up to number 8. Now let's add more names. Now I'll be adding Marcus, Julia and Olivia. See how it auto-generates new numbers based on data in column B. Let's do one more thing here. Delete one of the rows and it rearranges the entire sequence. Cool. isn't it? I'm 100% sure that you will use this technique going forward. And as a gesture of thanks, you can definitely think of hitting that subscribe button to help my channel grow. Give this video a thumbs up and share it in your network. Now let's continue with our second sequence. So far, we have looked at different techniques of generating numbers. Now let's look at series other than numbers. There could be a situation where you want a custom numbering for your data, such as number 1, number 2, and so on. Again, we will use sequence function, but there is a twist. Since we want a specific text to be appended at the beginning, we will specify this text in the formula. So, is equal to, in double quotes, your text, that is number. Here we will be reusing what we just learned in dynamic sequence, that is ampersand, sequence, and in sequence we will use another function that is called count a, and we will provide the range of column B, that is from B2 to B1000, and that's it. So this formula simply appends the text and that we have specified to the sequence. You can use any text of your choice such as series number or hack Excel. If you have any doubts about any function or feature, please feel free to post your question in comment section below. Now let's look at how can we generate date series. This series can be useful for recording data related to meetings, schedule, timesheets or attendance sheets. Here we want to create an attendance sheet for 5 employees for the month of January, year 2023. Enter the first date 2023-0101 and select the cell. First, simply use the fill handle and drag it until you reach the month end. We have all our dates of January month in this column. Second, double click the fill handle and it will generate dates up to existing data. So in this column, we only have dates until data in column B. Third is fill menu option. Select the date in A3 cell, go to fill menu and click on series. Select columns since we want our series to be generated vertically. Under type, select date and date unit will be day. Setting step value to 1 will add 1 day to every new value. No dates will be skipped. Setting it to 2 will skip 1 day and likewise 3 will skip 2 days. Let's set it to 3 and enter stop value to 2023-0131. So as you can see in the first cell, the date is 1st January and we have set step value to 3, so it will add 3 days to it, which means our next cell value will be 4th January. Likewise, the dates will be generated adding 3 dates to previous date until it reaches the stop value of 31st January. If you need to avoid weekends, change the date to 2023-0102, which is Monday. Select the weekday under date unit. Step value to 1 and enter stop value to 2023-0131. Here, we have created the sequence for weekdays by avoiding weekends. That is 2nd January to 6th January are weekdays, whereas 7th and 8th January are skipped as they are weekends. Similarly, we have January 9th to January 13th and so on. The sequence will be generated until it reaches the stop value of 31st January 2023. If you need to generate same date for every month, select month under date unit and set stop value to a date, let's say end of year 2023 12/31st. Here we have created sequence starting from 2nd January 2023. Dates are generated by adding 1 month to previous date. The first cell value is January 2nd, so next cell value will be 2nd February and so on until it reaches the stop value of December 31st, 2023. And the last is if you need to generate same date for upcoming years, select year under date unit and set stop value to a future date. For an example, for future date, we will take 2030, 12, 31st. Here, second value in date series is 2nd January 2024, which we get after adding 1 year to previous date in the above cell. It continues to add 1 year until it reaches the stop value of 31st December 2030. A small tip here, if you need dates in different format, simply right click and go to format cells and change it as per your choice. Now let's see how we can apply the series or sequence on alphabets. Here we will generate a series of alphabets from A to Z. Simply enter letter A in cell and use formula in the next cell, that is equal to character in bracket code cell number +1. This formula uses the ASCII value of a character, and after adding 1, it converts it back to corresponding character. If you need a series of capital letters, change small a to capital A and that's it. Simple. Only limitation here is we can only go up to Z. There isn't an easy way to generate series beyond Z. Now let's look at our last series of this video, that is Roman numbers. Let's see if we can print a series in Roman numbers like this. We already know the sequence function, so let's just generate numbers from 1 to 20 using is equal to sequence in parenthesis 20. Now Excel has a function that converts a decimal number to Roman number, so let's use it. It needs 2 arguments, but only one is mandatory. So we will type is equal to Roman and pass sequence function as an argument. That's it. Classy looking Roman numbers are on your screen. Also, you can use dynamic sequence formula here as well. That's it. I hope you must have learned new features about Excel and must have found this sequence guide video super useful. If so, don't forget to subscribe and check description for other related videos. See you in the next video. Until then, keep excelling.